Dear students, welcome back to a new mathematics session. In today's session, we shall discuss a new chapter, that is the third chapter from the NCERT textbook, Trigonometric Functions. Let's move on to the topic. As we all know that trigonometry means the study of the relation between the sides and the angles of a triangle. Relation between the sides and angles of a triangle, that is called trigonometry. So let's begin with angles. Let's recall some of the basic concepts of angles. Angle is a measure of rotation of a given ray about its initial point. It's a measure of rotation, how much a ray is rotated from the initial point. That measurement is called the angle. The original ray is called the initial side, and the final position of the ray after rotation is called the terminal side of the angle. So let's visualize this. So if you consider an angle that is BOA or AOB, OA is called the initial side and OB is called the terminal side. It means initially only OA was there, then we have taken OA and we have rotated this way and we have reached the point B. So OB is the final position of OA, that means the terminal side, and the meeting point of this terminal side and initial side, that is called O, that is the vertex. This is the anti-clockwise direction we have moved, and if you move towards clockwise direction, then the position will be like this. Means A is here, we are taking this A and moving towards B, means moving down along the clockwise direction. So here initial side is on top, terminal side is just below OA, and this is the vertex. The terms are same, only thing is that the way of rotation is different. Here we are rotating it in the anti-clockwise direction and this is in clockwise direction. Here the point of rotation is called a vertex. We are fixing at this point and we are rotating A, so this point is called the vertex, means the point of rotation. As we have discussed before, clockwise and anti-clockwise, let's discuss in detail. Clockwise means moving in the direction of clock. As we all know that how the clock is moving. Clock is moving from left to right. So let's visualize that one. See, for example, if you consider this one as a clock, this is our minute hand and it moves this direction. This direction means from left to right it is moving. So this is the clockwise direction, and anti-clockwise means moving in opposite of direction of the clock. As we know that the clock is moving towards right, then if we are considering towards left, means it is the anti-clockwise direction. Means you can see here we are from 12, actually clockwise direction means from 12 we have to come to 1, then we have to come to 2, 3, means we are moving towards right. Anti-clockwise means from 12 we are coming to 11, then from 11 we are coming to 10, we are coming to 9, means we are moving towards left. This is anti-clockwise direction. The next is anti-clockwise angles are positive. This is a very important point. Anti-clockwise angles. Anti-clockwise angles means this way if you measure an angle, this is positive angle. For example, when we measure this angle, this angle we will be marking as positive, and if you measure this angle, this is clockwise direction. If you measure this angle, we will be marking with a negative sign. Here this is plus 30. You can see there, you can see here this is the initial side and this is the terminal side, and we are moving towards left. So actual measurement is 30 and we have to put a plus sign. Plus 30 means we are measuring it on the anti-clockwise direction. Then here 30 is anti-clockwise, so it is positive. And next is the same 30 only, like this we are just keeping, means this is our initial ray and the terminal side is just down, means we are moving towards right. 30 degree we are moving towards right. Since we are moving it in clockwise direction, we are just using a negative sign. So here 30 degrees clockwise, so it is minus 30 degree. To make it positive, we go anti-clockwise. If you want to make it this 30 degree positive, means we have to go anti-clockwise, means this way. So this is minus 30. Minus 30, if you want to make it positive, we have to measure the reflex angle, means another portion we have to measure. Means this is 30, means around a circle or around a point The total angle is 360 degree. From 360 degree, this portion 30 degree if you remove, then we will be getting 330 degree. So the angle is 360 minus 30, that is equal to 330 degree. So this is the way we have to make a negative angle to a positive angle. Means here minus 30 degree is there, minus 30 if you subtract from 360, we are getting 330 degree. That is the positive value. To make it positive, we go anti-clockwise, that we have already discussed, because this is clockwise. When we measure it in clockwise direction, we will get a negative value. To make it positive, what we have to do is we have to measure the anti-clockwise direction. We have to measure the anti-clockwise angle here. This is the portion we have to measure. Instead of measuring directly, we can calculate it, subtract it from 360. 360 minus 30, that is equal to 330 degree. Here we must note angles are positive when it is measured in anti-clockwise. This is a very important point which we have learned from this slide. Means angles are positive when it is measured in anti-clockwise direction. Next, we shall discuss some of the basic terms which we use for measuring angles. First one is degree, second one is minutes, and the third one is seconds. The first one is quite familiar for us because up to class 10 we use this unit for measuring the angles by using protractor. See, protractor means we know that it is a semicircular shape equipment and it is having 180 degree, total 180 degree. Means here by using protractor, if you measure an angle, we write the answer in terms of degrees, like 7 degree, 10 degree, 15 degrees, 180 degrees and so on. And next two terms, that is minutes and seconds, that's what we are going to discuss here in detail. If a rotation from the initial side to terminal side is 1 by 3/60th of a revolution, the angle is said to have a measure of 1 degree. Written as 1, then power there is 0. This is the way we represent 1 degree. Let me explain in detail by using a diagram. One full circle total angle is 360 degree. Means one full circle is divided into 360 equal portions, and here 1 by 3/60th of a revolution means if you take one portion out of this 360, one portion out of this 360, that is called 1 degree. Means when we are using a protractor, one small mark or the space between one big mark or one small mark, or the space between two small marks, whichever it is, if you take, that is called 1 degree. Means see, this is 0 and the another line, blue line, it shows that it is the space between these two, that is a red and the blue lines, the space between these two, it shows 1 degree. And that is what it is mentioned. It is 1 by 3/60th of a revolution. One full circle is having 360 degree, and out of the 360 degree, one piece if you take, one part if you take, that is 1 degree. Then a degree is divided into 60 minutes. When you check here, the space between these two lines, red line and the blue line, the space between these two is very small. So if I just draw it separately, just a very small gap is there between two lines. So I'm just making it a little bigger and drawing. So maybe this one is considered as 1 degree. Okay, I'm just visualizing it by using a little bigger, by keeping bigger space between the two lines. And this we can consider as just 1 degree, just pretend as 1 degree. And this space is again divided into 60 parts. And a degree is divided into 60 parts, that is called 60 minutes. And a minute is divided into 60 seconds. Minute means what? Again, this is 60 portions we have divided this small space, and out of that the space between two nearby lines, that we can consider, and again that portion we can divide it into 60 portions, that is called 60 seconds. That is what here it is mentioned. And here 1 degree means it is, 1 minute, this is the way we represent 1 minute, 1 upside 1 dash, that is 1 minute, this is the way we represent. And 1 minute means 1 by 60th of a degree. 1 by 60th of a degree means 1 degree we will take and we will divide into 60 parts. Out of that, one part if you take, that is 1 minute. Next is 1 second, means 1 power double dash, that is 1 second we say. 1 second means again here 1 minute we take. 1 minute we will take, and from there we will divide that space into 60 portions, and out of that 61 portion, if you take, that is called 1 second. Then 1 degree is equal to 60 minutes and 1 minute is equal to 60 seconds. So this is the relation. 1 degree is 60 minutes and 1 minute is 60 seconds. Very important results. So just keep it in mind, these two relations. Next we shall discuss about another new term, that is radian measure. Up to class 10 we have learned, or we used degrees to write the measure of an angle. So now we are going to use a radian as the unit of, or the measure of an angle. So that is what here a radian measure we are going to discuss. Angle subtended at the center by an arc of length 1 unit in a unit circle. Unit circle means circle of radius 1 unit. Is said to have a measure of 1 radian. So here angle subtended at the center by an arc. So an arc is subtended a particular angle at the center. Arc is formed from where? It is of unit circle. Unit circle means the radius is 1 unit, means the radius of that particular circle is 1 unit. Is said to have a measure of 1 radian. So this definition, it may create some sort of confusion with you. Let's discuss by using a diagram. So here you can see this is an unit circle. Unit circle means circle having radius 1 unit. You can see here OA is the radius and OB is also radius. So these two radii, it is measured as 1 unit. And the arc length, the length of this arc means between the point A and the point B, that is called the arc which we have considered, and the length of this arc is 1 unit. Then we can say that the angle subtended by this arc at the center, that is here at the center, is 1 radian. So this is the definition of radian, means 1 unit circle. 1 unit circle means a circle having radius 1 unit, and in that 1 unit circle an arc length of having 1 unit is subtending a particular angle at the center of the circle. Then that angle is called 1 radian. That measure of that angle is 1 radian. Then next is minus 1 radian. As we know that when we measure an angle in anti-clockwise direction, it is positive. The angle is positive. But here you can see the same thing only, but we have measured this one in clockwise direction. Means the same thing only. It is an unit circle, means circle having radius 1 unit and arc length also having 1 unit. Thus this same arc means 1 unit arc is subtending an angle at the center, but we are measuring it in clockwise direction. That's why it is called minus 1 radian. Next is 1 by half radian. 1 by half radian means only we need to change the arc length, means 1 by half means 1.5 unit length of an arc is subtending a particular angle in a unit circle. Unit circle means having radius 1 unit. Then we can say that the angle measurement is 1.5 radian. This is positive because we are measuring it in anti-clockwise direction. Next is minus 1/2 radian. The same thing only. 1.5 unit length of an arc is making a particular angle at the center of a unit circle, and we are measuring it in clockwise direction. Then that angle measurement will be minus 1/2 radian. Now let's define radians in little more simple way. So here there is a unit circle. Unit circle means a radius 1 unit and an arc length we have considered, that is also 1 unit. Then this arc is subtending a particular angle at the center of the circle, that is called 1 radian. Here conditions are like this. Length of the arc is 1 unit. Surely this portion, that is the blue lined portion, that is the arc length, the length of the arc which is having 1 unit, and radius must be 1 unit. Then we can say that the angle at the center is 1 radian. So this is the 3 conditions which we need to apply. Length of the arc should be 1 unit and it should be a unit circle, means radius should be 1 unit. Then angle at the center will be 1 radian. So if in a circle of radius r, an arc length L subtend an angle theta radians, then L is equal to r theta. This is a very important formula. Length of the arc is equal to r into theta. R means the radius of the circle and theta means the angle subtended by that particular arc at the center in radians. Remember, this theta measurement should be in radians, not in degrees. So this is a very important formula. Please keep it in mind. L is equal to r theta. L stands for length of the arc, r is the radius, and theta is the angle subtended by the arc at the center in radians. Next, we shall discuss how to convert degrees and radians. As we know that previously we all learned the unit of angle in degrees. So if a measurement is given to you in degrees, we should know how to convert it into radians. And also if a particular measurement is given to us in radians, we should know how to get back to degrees. So this is what we are going to discuss here. To convert degrees to radians, the radian measure is equal to, what you have to do is just multiply pi by 180 with the given degree measurement. Pi by 180 into degree measurement. Okay, if the given measurement is in degree and if you multiply with pi by 180, then we will convert that one into radian measure. Let's take an example. Convert 45 into radians. 45 degree into radians. This unit is in degrees, so we have to convert this one into radians. Quite simple. What you have to do is just to take that 45, multiply with the pi by 180. 45 into pi by 180. That is, when you can just do the cancellation here. 45 and 180, if you cancel, you will get 4 times. So that is why the answer is pi by 4. Next is a radian measure. Radian measure means pi by 4. That is what we have got here. 45 degree in radians. Sorry, 45 degree. When we convert it into radians, we get as pi by 4. Next, to convert radians to degrees. Radians to degree means just to change the this portion. That means pi by 180 becomes 180 by pi. That's all. So degree measure is equal to 180 by pi into radian measure. If you want to convert to radian degree measure, then what you have to do is radian measure you have to take and multiply with 180 by pi. Then when we summarize, radian measure is equal to pi by 180 into degree measure, and degree measure is equal to 180 by pi into radian measure. So these are the two conversion formulas, just to keep it in mind. Radian measure, if you want to calculate, pi by 180 into the quantity which we have given, which you have got in degree measure, you have to multiply pi by 180 into degree measure. Degree measure, if you want to take, means pi 180 by pi into radian measure we have to take. Next, we shall discuss the exercise problems. Find the radian measures corresponding to the following degree measures. Degree measurements are given to us. We have to convert that degree measurements into radian measures. That's what the question. First one is 25 degree. We have learned a formula. Radian measure is equal to pi by 180 into degree measure. Means if a degree measurement is given to us, when we multiply this degree measurement into pi by 180, we will automatically convert that one into radian measure. That is pi by 180 into 25 degree. Our degree measurement is 25 degree. So let's do the cancellation here. With the 5 we can cancel 25. 5 5s are 25. Then with the 180 if you cancel, 3 5s are 15. And here balance is 3. 30 is 6 times. So 36. So the answer will be coming as 5 into pi. That is 5 pi by 36 radians. Next is minus 47 degree 30 minutes. This read as 47 degree 30 minutes. That is minus 47 degree 30 minutes. That is equal to, just we can split it as 2. Minus we can take out. 47 degree 30 minutes is 47 degree plus 30 minutes we can write. When we add, we are getting the same quantity. Then we have learned the 3 measurements. The first one is degree. The smaller one which was compared with the degree is minutes, and next to the smaller quantity is seconds. Degree, minutes and seconds we have to write. Then degree to minutes means 60 minutes is 1 degree. So degree to minutes, the unit difference is 60. The next is minutes to seconds, means 60 seconds is 1 minute. From that means from minutes to seconds, if we want to change it, we have to do the calculation with 60. Then when we go from bigger unit to smaller unit, here the bigger unit, as I have mentioned, it is degree is the bigger unit and minutes is a smaller unit. Then when we change from bigger to smaller, that means we have to multiply 60. Then when we are coming from right to left, that means smaller to bigger if we are coming, that means we have to divide with 60. Remember these 3 units, degree, minutes and seconds. and the connection value is 60, here also 60, here also 60, and from big to small if you move, we have to multiply 60, and from small to big if you come, you have to divide 60. Then for example, if 6 seconds to degree, if you want to come, there are two 60s, means we have to divide. Okay, we have to divide 60 into 60, that means 3600. That's what the conversion we do here. Then here for converting minutes to degrees, here there is 30 minutes are there. 47 of course already it is in degrees, and here 30 minutes are there. This 30 minutes also we have to convert into degrees. For converting minutes to degrees, minutes to degree means from right to left, minute degree, the connection is 60. It is coming from smaller to bigger, that's why we have to divide with 60. That is minus of 47 degree plus this 30 minutes we are changing as degrees, that is 30 by 60 degree, 30 by 60 degree. That is equal to minus of 47 degree plus, here 30 and 60 it is quite clear, when we cancel we will be getting as 1 by 2, because 130 is 30 and 2 30s are 60, so 1 by 2 will be coming. So that is what it is written, 47 degree plus 1 by 2 degrees. That is equal to, when we just to take the common LCM as 2, 47 into 2, 47 into 2 is 94 plus 1 divided by the whole divided by 2. That is equal to 94 plus 1, minus is outside, 94 plus 1 is 95 by 2. So here radian measure is equal to, now this entire term is converted into degrees. Previously it was one is in degree, another one is in minute, so this minute also we have converted into degrees. Finally we have got minus 47 30 minutes as minus of 95 by 2 degrees. Now we can convert this one entire quantity into radian measure. That means just multiply with pi by 180. That is equal to pi by 180 into minus 95 by 2. That is equal to, here when we check, pi into minus 19 by 72. Minus 19 by 72 means little bit of calculation we have to do. This 95, when we cancel 5 we will be getting as 1 5 is 5, then here it is coming as 13. Sorry, 45. 45 means 9 times it is coming, that is 19. 1 5 is 5, then balance is 4, 45 is 9 times. And here when we cancel we will be getting as 3 times 15, and there is 30 balance, that means 6 will be coming. And now when we multiply the numerators, 19 into pi, that is 19 pi, that is minus sign is there, then 36 into 2 is 72. Pi we can keep separately, so pi into minus 19 by 36 into 2, 72 is getting. Then that is minus 19 pi divided by 72 radians. This is the final answer in terms of radians. Next there are two sub questions. The first one is 240 degree, this we have to convert into radians. Another question is 520 degree, that also we have to convert into radians. So these two questions you will be doing as homework. Next we shall discuss the second question, find the degree measures corresponding to the following radian measures. Here pi value is given to us 22 by 7, means wherever pi is coming there we have to substitute this value. We are asked to find out the degree measures, and the given quantity is in radian measures. Previously what we have done is, the given quantity was in degree measures and we have converted that one into radian measures. Here just opposite of that, first one is 11 by 16. 11 by 16 is in radian measure. We have to convert that one into degrees. Formula, degree measure is equal to 180 by pi into radian measure. Previously radian measure we have calculated, radian measure is pi by 180 into degree measure. Here just opposite of that, degree measure is equal to 180 by pi into radian measure. So let's substitute the values. 180 divided by pi, pi value is given to us, that is 22 by 7 substituted, into radian measure, given radian measure is 11 by 6. Here denominator of 180 is 22 by 7. We have to take the reciprocal of this 22 by 7 and multiply with the 180. That is the easy way of calculation. 180 into 22 by 7 reciprocal is 7 by 22. We multiplied into the given quantity, that is 11 by 16. That is equal to little bit of rearrangement we have done, 11 into 180 into 7 divided by 16 into 22. This step is not mandatory. If you wish to write, or else you can just do the cancellation here itself. When you do the cancellation, we will be getting 1 into 45 into 7. How we have done the calculation, let's check. Here 11 and 22 we can cancel 2 times, and 180 we can cancel 4. 4 means 4 4s are 16, and there is 2 balance 20, that means 5 times 20 45. Then here 4 cancel in time, 4 4s are 16. That is the way we have got this answer. That is 1 into 45 into 7 divided by 4 into 2. That is equal to 45 into 7. When we multiply, 315 will be coming. You just multiply and check. Either you can do mental calculation. How? In the sense, 5 into 7. That is 7 5s are 35. 5 remainder 3. 7 4s are 28. 28 plus 3 is 31. This way mental calculation you can do, or else you can just write and do the calculation. Please don't copy. 4 into 2, that is equal to 8. Then what you have to do is just divide these two quantities. 315 when you divide with 8, what first step is 3. 8 3s are 24. 24 balance with 31 is 7. Then this 5 you have to bring down, that is 75 will be coming. Then 8 9s are 72. 9 8s are 72, that is written. The balance is 3. So we have to stop the division here because no more division is possible with the given values, or else you have to go with the decimal. So here what we are getting is 39 3 by 8 in a mixed fraction form. When we write 39 3 by 8 is the mixed fraction format. So here we will be writing as 39. This is a complete answer. This 39 will be in degrees, and 3 by 8 plus 3 by 8, that we have to write separately as degrees again. So 39 plus 3 by 8 will be coming. Both are in degrees only. 39 plus 3 by 8. Now this 3 by 8 is comparatively very smaller quantity. This one we have to convert into smaller unit than this degree. So what we have to do is, degree next smaller unit is minutes. So we have to convert this 3 by 8 degree into minutes. For that what we have to do is, we have to use this chart. For that we have to convert degree to minute. Means here degree to minute, bigger quantity to smaller quantity, multiply with 60. So we have already learned this one. For converting degree to minute we have to multiply 60. What we have to do is 39, no need to change, just to keep as it is, plus the smaller quantity we have to take 3 by 8 multiply with 60. Then this quantity will be changed as minute. That is equal to 39 plus, when we convert this one in here, just to do the calculation with little bit of cancellation we have to do here. 60 when you do when you cancel 2, we will be getting as 30. Let's go with the smaller cancellation. Then here when we cancel we will be getting 4. Then again with 32 is common, then we will be getting as 15. Then next here when we cancel we will be getting as 2. So what the answer, final answer is getting is 15 into 3, that is 45, divided by denominator is only 2. So 45 by 2, this is in minutes. Now 45 and 2 we can divide. 45 and 2 dividing time, directly also we can write 22 half is the answer, or else 2 2s are 4. Then there is no balance here, 0 is the remainder. Then 5 you have to bring down. Then 2 2s are 4, remainder is 1, balance is 1. So we'll be getting as 22 1 by 2, 22 half will be getting. That we will be writing here 39 plus 22 half minutes. Now again we have to split. This 22 is comparatively bigger when we compare it with this 1 by 2. So 39 plus 22 degree we have to 22 minutes we have to separate, plus 1 by 2 minutes we have to take again from this 22 1 by 2, 22 half. From this 22 half minutes what we have to do is 22 we have to separate, plus this 1 by 2 also we have to write separately. So now it is 1 by 2 minutes. Now what we have to do is, this is again smaller quantity. What we have to do is, this 1 by 2 minutes we have to convert it again to the smaller unit. That means minutes next to smaller units is seconds. So we have to convert minute to second. Minute to second means bigger to smaller. Bigger to smaller means again multiplication with a 60. That is multiply with the 60. What we have to do, 39 degree plus 22 minutes, let it be there, plus we are now concentrating on this fraction. That is 1 by 2 into 60 converted into seconds. Minutes converted into seconds when we multiply with the 60. Here quite simple, 2 and 60 when we cancel we will be getting 30. That is 39 degree 22 minutes 30 seconds. So when we write the answer we can write it together by removing the plus symbol. 39 degrees 22 minutes and 30 seconds. This is the final answer. Little bit of calculations are there, but it is quite easy when you are using this chart, and just a little bit of concentration if you keep, then it will be very easy to solve these questions. Next we shall discuss the second question, that is -4. -4 is in radians. We have to convert this one into degrees. We know the formula, degree measure is equal to 180 by pi into radian measure. Quite similar to the previous question, just substitute the value of pi since it is given to us, 180 by 22 by 7 into -4. Take the reciprocal of 22 by 7, multiply it with 180, minus 180 into 7 by 22 into 4. So what we have to do is a little bit of cancellation we can do here with 4. 2 is common, so 2 2s are 4, and here when we check it is 11. So there is no other cancellation is possible. When we multiply minus of 180 into 14, 180 into 14 is 2520. Denominator is having only 11. Just multiply, okay, 180 into 14, multiply and check this answer is getting or not. Simply don't copy from this slide, okay. That is equal to, go for division, 2520 divided with 11. So 25 is first 2 digit. When we consider 2 11s are 22, balance is 3, and bring this 2 down again 2 times only will be going. 11 into 2 is 22, and 32 and 22 subtraction time we will be getting 10 balance, and there is one more 0 is there, bring down, that is 100. 9 times will be going, 9 into 11 is 99, so the remainder is 1. So we will be getting the answer as minus, this one we can write it as degree as before, 229 degree plus 1 by 11. How we write the mixed fraction form, same form only, but we have to write it this one first, then plus this one as a fraction, 1 by 11. This 1 by 11 also in degree, but this is smaller quantity as we compare with this one, so we have to convert this one into the smaller unit. So degree, next smaller unit is minutes. So what we have to do is, by using this chart, degree to minute conversion is multiply with 60. Then that is minus of 229 degree plus 1 by 11 into 60 minutes that we have got. Now here 60 we have to divide with 11. No cancellation is possible here, just do the division. 60 by 11, when you check, 5 11s are 55, balance is 5. So we can write this as minus of 229 degree plus, here we can write 5 by 11. So we can write as 5 by 11 minutes. Again this one we have to split, we know how to split, that is minus of 229 plus this 5 by 11 we can split as 5 minutes plus 5 by 11 minutes. Both are in minutes only, but we have to split it, that's all. Then what we have to do is converting the minutes to seconds. This is 5 by 11 is very small when we compare with this 5. So this quantity we have to change it to again smaller units, means minutes, next smaller unit is seconds. So 5 by 11 we have to convert into seconds, just to multiply with 60. So minus of 229 plus 5 minutes plus 5 by 11 into 60 seconds. Now what we have to do is minus of 229 plus 5 minutes plus, here also cancellation not possible, so just to multiply 5 into 60, that is 300 by 11 seconds. Next just to divide 311 when 300 and 11 when we divide, first two numbers 30, 2 into 11 22 will be coming, so 22 and 30 the difference is 8, bring that 0 down, so 80 will be coming. 7 times will be going with 11, 11 7s are 77, remainder is 3. So we can write this one as minus 229 degree 5 minutes. Then we can take this one 27. This 3 by 11 we can stop, because up to seconds only we know how to do, so the balance no need to take. So 3 by 11 no need to take, only up to 27 we can take, because division is continuing here, that's why. So this 27 is in seconds. So this is an approximate answer, because 3 by 11 we didn't take, that's why we can just write nearly minus 229 degree 5 minutes 27 seconds. Next we shall discuss the third question, 5 pi by 3. So here pi is given to us, so it is easy for us to do the calculation, no need of substitution here. I will show you how. Degree measure is equal to 180 by pi into radian measure. In our radian measure there is pi, so this pi and that pi will be cancelled, so no need of substitution. That is 180 by pi into 5 pi by 3. So when you do the calculation here, you will be getting the answer as 300 degree. So if you want, I will show you the calculation. That is pi we can cancel, and 3 and 190, that is we can cancel, and 6 3s are 18, and one more 0 will be coming. So 60 into 5 is 300 degrees. Next is 7 pi by 6. So that portion you will be doing as homework. Move on to the third question. A wheel makes 360 revolutions in 1 minute. Through how many radians does it turn in 1 second? Here the condition given to us is a wheel. Wheel means circular shape. Wheel is in circular shape. That wheel makes 360 revolutions. Means 360 times it is rotating in 1 minute. Through how many radians does it turn in 1 second? In 1 second, how much angle? Means it is in radian measure. It is turning. That is what the question. Here, number of revolutions in 1 minute it is given to us. That is 360. From the question, we are writing number of revolutions in 1 minute. That is 360 revolutions. That is, number of revolutions in 1 minute means 60 seconds. Number of revolutions in 60 seconds is equal to 360. Why we are writing in second terms? Because we are asked to find out the angle in which this wheel is turning in 1 second. That is what we have to find out in radians. So that's why this minute we have to change it into second format. 1 minute means 60 seconds is equal to 360. From here, number of revolutions in 1 second. From 60 seconds, it makes 360 revolution. From 60, if you want to convert it into 1, just to take the 60 to the right side. That's all. That is division. So number of revolution in 1 second is 360 by 60. 360 by 60, it is quite familiar for us. It is 6. Means in 1 second, it makes 6 revolutions. 6 times it is rotating. Now, angle made in 1 revolution is 360 degree. Angle made in 1 revolution is 360 degree. How 360 degree? Means it is in circular shape. Just you can see that a wheel is in circular shape. So when just imagine that it is circle in shape, even though it is not in circular format. Just pretend that it is in circular format. Okay, suppose that this is a wheel. Wheel means it is in circular shape. Circular shape means one complete rotation it takes 360 degree, because we have learned that around a point the angle is 360 degree. That's why it is written angle made in 1 revolution is 360 degree. One time it is rotating time, it turns 360 degree. Angle made in 6 revolutions, because in 1 second it is making 6 revolutions. 6 times it is rotating. That means 1 time 360 degree means 6 times means 6 into 360. That is in degrees. We have to convert this one into radians. So we know that it is a conversion table that we have discussed before, and here radian measure is equal to pi by 180 into degree measure. So that is what the formula, because we want the answer in radians. Radian measure is pi by 180 into degree measure. Now this is in degree measure for us. That is pi by 180 into 6 into 360. So what we have to do is a little bit of calculation we do. Then after calculation we will be getting the answer as 12 pi. Again I will show you the calculation here. 6 and 190 when we cancel, it is 6 3s are 18 and 30, and here 0 can be cancelled, and 3 and 36 when we cancel will be getting as 12. So this is the answer, 12 pi. Pi we didn't substitute, so 12 pi is angle made in 6 revolutions. Move on to the fourth question. Find the degree measure of the angle subtended at the center of a circle of radius 10 cm by an arc of length 22 cm. Use pi is equal to 22 by 7. Find the degree measure of angle subtended at the center of a circle of radius 100 cm by an arc of length 22 cm. There is an arc. Arc means a part of a circle. The length of the arc is 22 cm. That arc is subtending a particular angle at the center of the circle whose radius is 10 cm. And we are asked to find out the value of that particular angle in which that particular arc length or particular arc is forming with the center of the circle. So here visualization of the question is like this. There is a circle whose radius is 10 cm, and there is also an arc whose length is 22 cm. This is the arc, means portion of a circle, part of a circle. So 22 centimeter arc, and this arc is making an angle. This is an angle, that is we have marked as theta. With the center of the circle, we are asked to find out the value of this theta in degree measurement. Okay, so here given to us, length of the arc is given L, 22 centimeter, radius of the circle is given 100 centimeter, and angle theta we have to calculate. And we know the formula, L is equal to r theta. Length of the arc is equal to radius into the angle in which the particular arc is making with the center of the circle. So L is equal to r theta. That is equal to L, we have 22, is equal to r is 100 into theta. Just we have substituted. So theta is equal to, bring this 100 to the left side, means it comes the denominator. So 22 by 100 radians. This is in radians. Whatever quantities it is given to us, it is in radians. Whatever answer we are getting also, it is in radians. Make sure that it is converted into degree measure. So here degree measure is equal to, the formula is 180 by pi into radian measure. So just to substitute, 180 by pi into radian measure is 22 by 100. Here when you do the calculation, that is 180 into pi value is here pi value is 22 by 7, but when we multiply it with the numerator, it will be taking the reciprocal, 7 by 22 into 22 by 100. One step I have avoided here, substituting the value. I think it is familiar for you. Or else you can just simply substitute here pi as 22 by 7. I have removed that one and just taken the reciprocal and multiplied here. That's all I have done. Then when you do the calculation here, you will be getting as 126 by 10. How we have got, I will show you that. Here 22 and 22 we can cancel, and here that is 10 and this 0 we can cancel, and that much only. There is no other way we can do. There is denominator 110 is there here, and when you check the numerator 18, there is also 2. When we compare 10 and 18, 2 is common. We can cancel, but I'm not cancelling because we are going to use this 10 in the denominator. That is 126 by 10. 18 into 7 is 126 by 10 we have got. So 126 by 10 when you divide, you'll be getting 1 time, that is 10 we have written, balance is 2, 26. Then 26 also 2 times it will go, 10 into 2, 20. The remainder is 6. So what we have to do is 12 degree. The quotient what we have got is 12. We have taken 12 degree plus 6 by 10. It's quite familiar for us. In the previous questions also we have done. 6 by 10 is in degrees. That is equal to, we know the chart here, and this smaller quantity, that is 6 by 10 degree, we have to convert it into a smaller unit, that means minutes. So what we have to do is just to multiply with 60, that is 6 into 60 by 10, or 6 by 10 into 60. Here also we can do cancellation, 10 10 we 0 0 we can cancel, that we will be getting as 12 degree plus 36 minute. I am not showing the calculation here, quite simple, that's why 0 0 cancel, 6 into 6 is 36 minutes. So 12 degree 36 minutes. Then we can write by avoiding plus sign here, 12 degree 36 minute is the answer. Next we shall discuss the fifth question. In a circle of diameter 40 cm, the length of a chord is 20 cm. Find the length of the minor arc of the chord. Here, if in a circle of diameter 40 cm, there is a circle whose diameter is 40 cm. Length of the chord is 20 cm. Chord means a line segment joining the 2 points which are on the circumference of the circle. That is called the chord. Length of the chord is 20 cm. We are asked to find out the length of the minor arc of the chord. I will show you what is minor arc. Let's visualize this one. Here there is a circle and diameter is given to us 40 cm. This is the diameter 40 cm, and there is a chord, that is BC. Chord means 2 points are on the 2 end points are on the circumference of the circle. That is called the chord. That means BC is the chord. You can see B and C are on the circumference of the circle. So BC is the chord. Length of chord is 20 cm. That is what it is given. Find the length of the minor arc of the chord. You can see here length of the minor arc means this BC is dividing the circle into 2 portions. One is above BC, another one is below BC. So comparatively, which is smaller in length, that is called the minor arc. Which is bigger in length, that is a major arc. So this portion is the major arc, and BC, this portion is a smaller arc, because this BC line segment BC is dividing this portion, below portion, is smaller in length. That's why this is called the minor arc, BC. Now let's do a little bit of calculation here. Given diameter is 40 centimeter, that is we have marked in the diagram. Then radius also given to us, that is BC 20 centimeter, that we have mentioned. Then in the figure AB, that is this portion, AB is our radius. Radius we know that it is 20 centimeter. Then AC also radius only. You can see here this portion, AC also radius only, that is also 20 centimeter. And BC, our chord, that is also 20 centimeter. Then when you check this triangle ABC, all these three sides AB, BC and ACA are of same length, 20, 20, 20. Means triangle ABC is an equilateral triangle. All three sides are equal. Equilateral triangle means this angle is quite simply we can write, that is 60 degree. Means 180 by 3. All three sides equal means all three angle also will be equal. Total 180 degree is the angle. Dividing equally three portions means each one will be getting 60. So AB equal to AC equal to BC equal to 20 centimeter. Triangle ABC is equilateral, we have discussed. Hence angle BAC is 60 degree. Angle BAC is 60 degree. Why? Means in an equilateral triangle, three sides are equal. Same way, three angles also will be equal. So three equal angles means 60, 60, 60 will be coming. So total 180. So theta is equal to 60 degree. Here we are asked to find out the length of the minor arc. Means length of this arc BC we have to find out. Before that we have to convert this one into radians, because all our calculation of angle should be in radians. But here we have learned previously that 60 degree, the equilateral triangle angle is in 60 degree. So that degree we have to convert into radians. 60 into pi by 180. That is equal to 60 and 180 we can cancel 3 times. We will be getting as pi by 3, that is theta. Next we have to go for using the arc length formula. L is equal to r theta. That is equal to r radius, that is 20. Our theta in radians is pi by 3. So 3 and I think here cancellation is not possible. Directly we can write it 20 into pi, 20 pi by 3. So 20 pi by 3 we have got an answer. Hence the length of the minor arc of chord is 20 pi by 3. Move on to the sixth question. If in two circles arcs of the same length subtended angles 60 degree and 75 degree at the center, find the ratio of their radii. Here if in two circles are mentioned, arcs of the same length. In two circles also we are considering the same arc length. Subtended with first circle it is 60 degree, and in the second circle the same arc length is making 75 degree at the center. Find the ratio of their radii. Radius ratio we have to calculate. So there are two circles, and the first circle radius r1 and second circle r2 is the radius, and arc length is this one. Both are we are considering as L, because two circles arc of the same length. That's why same alphabet we can use to measure, to represent length L. Here also length L. This arc length is making 60 degree with the first circle, and this arc is making 75 degree angle of the center of the second circle. So here the radii we denoted by r1 and r2. Then length of the first circle, length of the arc of the first circle, that is L is equal to r1 theta. L is equal to r theta is the formula. Here there are two radii are there. That's why we are taking L is equal to r1 into theta. R1 into theta is 60 degrees. So convert it into radians. R1 into 60 into, if we are converting degree into radians means pi by 180. So R1 into 60, 180 we can cancel 3 times. So R1 into pi by 3 will be coming. Okay. Then next portion, length of the arc of the second circle. That is this one. Length of the arc of the second circle means L is equal to R2 theta. Both we are using L only because same arc length, same quantity. That is equal to R2 into theta is 75 degree. We convert the 75 degree into radians. That is R2 into 75 into multiply pi by 180. That is equal to R2 into, when we cancel here, 5 and 180 will be coming. How we are getting 5? Let's check. Here with a 5 we can cancel. 5 means 1 time 5, then there is 25 balance, that is 15 times will be coming. Then here 5 if you cancel, it is 5 3s are 15, and here it is coming as 36. And with 3 we can cancel, that is 5 3s are 15, and when 3 cancelling here it will be coming as 12. So this is the way we have got r2 into 5 pi by 12. Then it is given that the arcs are of the same length. That is what it is mentioned in the question. That means length of the first arc and length of the second arc are equal. So we have got the lengths here. This is r1 pi by 3 is the first length and r2 5 pi by 12 are the second length. They are equal. Here we want the ratio of the radii, means r1 divided by r2 we want. R2 you just bring here, and this pi by 3 you just bring on the right side. So R1, this R2 coming to the left means it will be coming in the denominator. That's what it is written, R1 by R2 equal to this pi by 3 entirely we have to bring to the right side. Quite simple, just take the reciprocal and multiply. How we multiplied previously, pi value like that. Take the reciprocal. That means 5 pi by 12 into this pi by 3 coming to the right side means it will be coming as 3 by pi reciprocal. Then when we do the cancellation, we will be getting r1 by r2 is equal to 5 by 4. Just I will show you the calculation also. Here pi and pi can be cancelled, and 3 and 12 we can cancel 4 times. So the answer will be r1 by r2 is equal to, numerator there is 5 and denominator there is 4. So ratio of radii is equal to 5:4. This is the answer. Move on to the 7th question. Find the angle in radian through which a pendulum swings if its length is 75 cm and the tip describes an arc of length. Here first one is 10 cm. Let's go through the question. Find the angle in a radian through which a pendulum swings. What is pendulum? I will show you just in the diagram. Which a pendulum swings if its length is 75 cm. Length of the pendulum is 75 cm and the tip describes an arc of length 10 cm. So here this is the visualization. There is a pendulum. Pendulum means there is a spherical ball here and one end will be tied here and through a string. And the pendulum, just when we pull and release, it just swings, means it comes here and go back, here and go back. It goes like this. This is the movement. And at a particular angle theta here, it creates an arc length of 10 cm, means only a particular portion it is considered here. So initial position was here and it comes here and again it come back and it moves like this. This is the pendulum movement. And the length of the pendulum is given to us 75 cm and the arc length in which this pendulum forms, that is 10 cm. We have to find out the angle in radian. So this angle we have to calculate. L is equal to length of the arc, that is 10 cm it is given to us. R radius also given to us 75 cm. L is equal to r theta, we know the formula. Length of the arc is equal to radius into theta. That is 10 is equal to 75 into theta. 10 is our length of the arc, 75 cm is the radius and theta is the angle. So here when you take theta, when you keep theta on the right side and bring 75 to the left side, means 10 by 75 will be coming. That is theta is equal to 10 by 75 radian. Okay, this is the measurement, 10 by 75 radian. Now here 10 by 75 when you cancel, here we can cancel 5 here, 5 2s are 10, then 5 15s, that is 75. So 2 by 15 radian. Next there is one more question, that is 15 cm and another question with 21 cm. These two questions you will be considering or you will be doing as homework. Dear students, today we have started a new chapter, that is trigonometric functions, and there we have discussed about angles and its degree measurements and radian measurements, and we have learned how to convert degree measurements into radian measurements and vice versa. And also we have discussed about the arc length. Hope it is clear for you all, and if you have any doubt, please note it and keep. We will discuss it during the discussion session. Thank you for watching.